Hi, in this video we are going to discuss about the path independence, potential functions and the conservative field. This is very simple actually, right? So first we are going to define what do you mean by a path independence. Path independent means what? From the word itself we can see that it is path independent. It does not depend on the path. Which path? That is, we are going to consider a domain D. Domain D means that is an open connected set. Suppose this is a domain. Okay. Consider 2 points A and B is here. Right. Consider a path from A to B. Consider a path from A to B. This is the path. Find integral from f dot dr over these path. Right. I'm considering this is path 1, this is gamma 1, and next I'm choosing this is a path, this is gamma 2, next I'm choosing this one, gamma 3, this is gamma 1. This we have found, that is, and again gamma 2 f dot dr, find out this, again integral over gamma 3 f dot dr, we have to find. Right? If this integral value is same for all paths from A to B, consider all the paths from A to B. If the line integral is same for all the paths, right? This is true for any A and B in this domain. Okay? Then we say that the line integral is, line integral is path independent. Path independent in D. Path independent in D. That is integral f dot dr is path independent. Path independent. Okay, and if this line integral is path independent, then this type of field f is known as the conservative field. Conservative field. Okay, if the line integral f dot dr is path independent, then that f is known as the conservative field on the domain D. Okay, is clear? Yes. Next, we are going to define what you mean by a potential function. Potential function. F is a field. F is a field defined on D. Okay, and also suppose that F is equal to del into F. For some scalar f equal to del f. For some scalar function f on D. Then this f is known as the potential function for f. F is a field defined on D. F equal to del f. If f can be written as del into gradient of another scalar function, then that scalar function is known as the potential function for the vector field f. Right? If capital F can be written as the gradient of a scalar function f, then this scalar function is known as the potential function for the vector field f. The vector field f. Okay. And next is we have to evaluate that is equal to, that is path independent. Path independent means this integral from a to b f dot dr is always is equal to integral from a to b. If f is a if small f is a potential function, then this can be written as del f dot dr. This is equal to, actually this is equal to integral from a to b. Del f is equal to fx into I plus fy into j plus fz into k dot dxi plus dyj plus dzk. This dot product is fx dx plus fy dy plus fz dz. Right? This is actually, this is the derivative of f. Okay. This is equal to f of b minus f of a. Okay. This is the meaning of this one. That is, this is equal to fb minus fa. How can we done this? Dou f by dou x into dx plus dou f by dou y into that is a derivative df by I can write this as, that is integral from a to b, that is dou f by dou x into dx plus dou f by dou y into dy plus dou f by dou z into dz. Right? This is equal to, what happened to this one? This is actually, this is integral from a to b, that is a derivative of f. Is equal to fb minus f. Right? This is fb minus fa. That means this line integral is path independent and path that value is equal to fb minus fa. Next, we are going to define a theorem. That is a fundamental theorem of line integral. There is a fundamental theorem of line integral. I don't know what it is. Okay. Listen, this is a fundamental theorem of line integral. What we have to mean this? Let capital F is equal to, that is, listen this 1 and 2. Capital F is equal to mi plus nj plus pk with a vector field whose components are continuous throughout an open connected region D in space. Then there exists a differentiable function f such that capital F is equal to del f, which is equal to dou f by dou x into y plus dou f by dou y into j plus dou f by dou z into k. This is f is equal to this one. If f is a vector field whose components are continuous throughout an open connected region, then there exists a differentiable function f such that this exists. Right? If and only if for all points a and b in D, the value of this integral is independent of path. That means this is scalar potential exists if and only if the line integral is path independent. Okay. If the integral is path independent of the path from a to b, its value is integral f dot dr equal to fb minus f. Right? So here f is equal to del f if and only if integral is path independent. Right? So in this proof, f is equal to del f implies path independence. We are going to prove this. Right? Suppose a and b are the 2 points in D, 2 points in the domain, and gamma t equal to, this is a general equation. smooth curve. F is differentiable function of t. Then df by dt equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt plus dou f by dou z into dz by dt. Right? This is actually del f dot dx by dt into del f if dou f by dou x into I plus dou f by dou y into j plus dou f by dou z into k. This is dx by dt into y plus dy by dt into j plus dz by dt into k. This is del f dot dr by dt. It's equal to, given that del f equal to capital F, f dot dr by dt. So, therefore integral of C, f dot dr equal to from t equal to a to t equal to b, f dot dr by dt into d, which is equal to df by dt into dt. How will you calculate that? This is equal to f dot dr by dt equal to df by dt. So df by dt into dt. So this is f of g of h of t, k of t from a to b. That is fp minus fa. This is fp minus fa. So we can see that this is path independent and the value is equal to fp minus fa. Right? The reverse, the converse is we are not considering. So next we are going to do one problem in this. The question is find the work done by the conservative field given that capital F is equal to yz into I plus xz into j plus xy into k. Okay. Smooth curve joining from -1, 3, 9 to 1, 6, -4. Right? How will you calculate this? This is integral from a to b. F dot dr can be calculated as integral from a to b del f dot dr. Del f dot dr. Then next is f the del f dot dr is equal to, which is equal to fb minus fa. What is f here? How will you find out this f? Right? We have to find out this f. Okay. How will you, from the textbook they have got that this is equal to xyz. Okay, that is we are going to discuss it later, right? I'm going to move on to this theorem 2. Before that, I will. How will you find out this? How can you find out this? F is equal to del f. I will show you that. I will show you. F is equal to del into f. F is equal to, actually this is mi plus nj plus pk, which is equal to del f is equal to dou f by dou x into I plus dou f by dou y into j plus dou f by dou z into k. And we will get dou f by dou x is equal to m, dou f by dou y equal to n, and dou f by dou z is equal to p. Right. So after that, I think our time limit is over. So we can discuss the remaining in the next video. Okay, thank you.